In the previous two lessons, we talked about volume with disks, because if we looked at the side of our figure, or the side of our figure looked like a circle because of the way we were rotating around. And so the question may be that, with one graph, that was fine, but what if we have two graphs? And so this is really going to combine what we did at the beginning of this unit, where we found the area between two curves, with what we did most recently, which is volume. Let's take a look at this graph. We have y equals negative square root of x plus 5 and y equals 2. And what we want to do is think about rotating this around the x-axis. So when we think about rotating it around the x-axis, which is all the way to below what we've got, one of our first things we can do so we can imagine this is just graph the reflection across the x-axis. So that would look like this. And then from there, it's like we're connecting our outermost functions together in a circle on either side. We're connecting our innermost functions in a circle. And then just trying to make this look 3D. I'm really proud of this figure that I did myself. I didn't steal it from the internet. I made it all by myself. And so this is the perspective we would get if we were looking at the left side of this after we've rotated it. So this bottom part and the top part are coming from our square root function. The middle of this would just go straight through as a straight horizontal line. And so on the other side of this, if we could see that circle, the middle of it would actually be the same size, even though the outside is not. And so we have to think about what we would do differently. For instance, if we tried to find the area, because we said that volume is area of the base times height, if we find the area of this shape we've got, which would actually be circles, not ovals, because of 3D perspective. If we think about how this is going to be not super great, but pretend these are circles. If we've got a circle inside of a circle, and the inside circle is centered in there. I guess it doesn't have to be centered, but it would be in this case centered in the middle there. If I want the area of this, what do? I find the area of the outside, the bigger circle, and I subtract the area of the inside circle. So this is going to give us a formula to use that is similar to what we used with disks, but is also similar to what we used with area between curves, because we're going to have to use both of our functions, and we're going to have to square them because we're doing pi times the radius squared. We've got circles here, so we need to know how far is it to get to one side of our little circle, how far is it to get to one side of our big circle. So those are f of x and g of x are how we're figuring out the radius. We're squaring them. There's pi on the outside. The biggest thing to make sure you know on this is just like our area between the two curves, where we did the top curve minus the bottom curve. Here, f of x is our outer function, if we imagine rotating, and g of x is the inner function. Now for the most part, that's going to mean the function on top comes before the function on bottom. But if they had given us this originally and told us to rotate it around the x-axis, then actually we'd use the red line, which is on the bottom, as our outside, and the purple line, which is on top on the inside. Most of the time they'll probably give it to us this way, but just in case, instead of thinking of it as top and bottom, we want to think of it as which function is giving the outside of my figure and which one is giving me the inside of my figure. So let's give this a try on some examples. We've got y equals 5, y equals 2 over x, and x equals 2 that are our boundaries. We're just going to rotate this around the x-axis so that we don't have to worry about any shifts or anything like that. We want to find the volume. I'm going to go ahead and sketch the curve so I can see what's going on here. We've got y equals 5, which is a horizontal line at 5. We've got x equals 2, which is going to end up being one of our boundaries. Spoiler alert. And then we've got this equation y equals 2. Now, y equals 2 is a reciprocal function. It has asymptotes at 0 and 0 each direction. And so if I plug in 1, I get 2. If If I plug in 2, I get 1 because I'm dividing. And then from there, it heads towards 0 each direction. But it never quite touches. So what we want to do is think of the region between y equals 5 and y equals 2 over x. So y equals 2 over x is this line up here, and then my green line is y equals 2 over x. Between those is this inside part right here. We're basically trying to figure out, in some ways it's like we're doing the area of this, but we're adding to that some squareds and a pi, which is really going to give us the volume if we rotated this around. And so this would look really weird, by the way, if we rotated it, because the outside is just this circle that would stay the same the whole time. And so from the outside, it doesn't really look super different. But on the inside, it starts off really, like basically it starts off touching the circle, and then towards the inside, it starts going like, I feel like I did that backwards. Yeah, like this or something like that, so that it's headed each direction. So it's kind of like a funnel-y looking thing, but where the outside is a cylinder. That's not super important. Let me get rid of that. What is important is saying which one of these is our outside function and which one is the inside. And so y equals 5 is going to give us the outside, because if we reflect it down here to the bottom, like that's going to be our bigger, like that's our bigger radius that we're finding. So this is going to be our f of x in our formula, and then the 2 over x is going to be our g of x, so it's going to come second. When we set this up, one of the things we need is our boundaries. So we're stopping at 2. The question is, where are we starting? We're starting right here where 2 over x is equal to 5. Well, I don't know where 2 over x is equal to 5, so let me figure that out real quick. To solve this, I would times by x on both sides and get 2 equals 5x. So then I divide by 5 on both sides and get x equals 2/5. So this starts at 2/5 and stops at 2. They told me about 2, which was nice of them. But if that ever happens, that you're like, I don't know where they start. If it's somewhere that you have an intersection, and in this case, if we graph this on our calculator, we wouldn't have been able to tell from our calculator. Well, you set your equations equal to each other and solve, and that will tell you where they're intersecting. Inside of our integral, we need to do f of x squared, so 5 squared, minus g of x squared, so 2 over x needs to be squared, dx. And one of the things with this whole squaring process is that you need to make sure that you're following our rules that we have in mathematics, like 5 squared is easy, that's going to be 25. But when I square 2 over x, it squares the 2 and the x. So that makes it 4 over x squared, which we're going to rewrite as 4x to the negative 2, so we can use the power rule. Speaking of the power rule, let's use the power rule to solve this integral. We're going to have pi. We're not going to have the integral, we're solving the integral. We're going to have pi, and that's 25x, because if it doesn't have an x, it gets an x, minus 4x, we add a power and get negative 1. We divide by that power and get negative 1 again. So this is 2/5 and 2. So pi, we've got 25 times 2. I would like to rewrite this. This is really plus 4 over x. So 25 times 2 plus 4 over 2. If you're just plugging it into the calculator, you don't really have to rewrite it, but if you're doing it by hand, it's easier to think of it as a positive exponent on bottom. When I plug in 2/5, that's 25 times 2 over 5 plus 4 over 2/5. If you weren't already like, man, I should just plug this in your calculator, that last part, whoops, that last part really does it, most likely. But really, it's not that bad. Like 25 times 2 is 50, and 4 divided by 2 is 2, so that's 52 for that first part. This cancels and leave me with 5, so that's going to be 10. When you do 4 divided by 2/5, you multiply by the reciprocal and get 10, so that's 10 plus 10, which is 20. So we need to just do 52 minus 20, which is 32, and don't forget to put the pi with it. So that's the gist of it. The only thing that we really need to worry about is making sure we understand which function is the outside, which function is the inside. If we may run into some kind of weird graphs that we have to deal with, and so we can look at these next examples. And one good strategy mathematically is that now that you've seen one, pause the video and try this one on your own and see how it goes. And if you get stuck, that's how you know that you need to keep watching. If you get to the end and you don't get the same answer, then you have to figure out, is that a little mistake or is it a big mistake? If you end up with the right answer, then you can probably just go on and try to do your assignment. So we have 3 lines here. Y equals 1 is one of them. That's either going to be our top or our bottom curve. We've got x equals 0, which means the x-axis is a boundary, not x-axis, oh, the y-axis is a boundary for us. So I'm not going to draw that because it's already there, it's the y-axis. So y equals the cube root of x. When you plug in 0, you get 0. When you plug in 1, you get 1. When you plug in 8, you get 2. Now I can do the same thing on the other side. Whoops. Got a little off there. So here's what my graph looks like. And we want what's between y equals 1 and y equals the cube root of x. So what is between the red line and the green line and x equals 0? So I'll draw that down here. Here's my boundary. That's going to be this inside part. This little bitty bit. We're trying to take that and rotate it around the x-axis. And so this actually kind of looks similar to our last one, where this time on the left side, we're basically just going to have a circle for this, because on the left side it's really only mattering what y equals 1 is, but then as it goes through, it's going to have this funnel kind of thing happening. So hopefully you're not having too much trouble visualizing this. But if you are, find somebody who isn't having problems with it, and maybe they can explain it to you or something like that. Let's set up this integral. Pi, the integral, we're starting at 0. They told us about that one. And then we want to use this intersection point at 1. We only need the x value, which is 1. Our outer function is the y equals 1 function. So we're going to do 1 squared minus. And then our inside function is the cube root of x. And so if you did try to do this yourself, you may have gotten stuck there at how do I square a cube root? They don't cancel each other out, in case you were hoping that that was the case. Only square roots and squareds cancel, or if this was a cube root cube, that would cancel. They have to be the same number for that to work. So we want to rewrite this with a rational exponent. The bottom number is your root, the top number is your power. So it's squared over the cubed root, and we get this. Now we can use the power rule, which means that 1 needs an x. When I add 1 to 2/3, I'm really going to add 3 over 3. So that's x to the 5/3 divided by 5/3. Now when we do that, when I divide by 5/3 and there's nothing in front of x except this minus sign, what it does is it flips it so that it's 3/5. So this is minus 3 over 5 x to the 5/3. And then we're going to plug in 1 and 0, which won't actually be super difficult. The 0 part of that will just be 0. So this is 1 minus, I don't know why I wrote a 2 there. That was a 3, sorry. 1 minus 3/5 times 1 to the 5/3. And then when I plug in 0, I would get 0. Now, 1 to any power, including 5/3, is just 1. If you had something other than 1, you would want to cube root first and then raise it to the 5th power. You can actually do it in either order or plug it into your calculator. But if you're doing it by hand, it's easier to cube root it and get a smaller number and then think about the 5th power than to do the 5th power and then try to cube root. So this is 1 minus 3/5, which is 2/5. So this is 2/5 pi for our answer for this one. Now we want to do one more. And again, you can pause the video and see how it goes, or you can just follow along. We have 2 graphs here and no other information. So that's interesting. If I graph this line 2x plus 2, it starts at 2 and goes up to over 1. So if we keep it going both directions the best we can, something like that. And then we're going to graph y equals x squared plus 2. So we're going to start at 2 and go up 1 over 1 both directions. And then at 2 we'll be all the way up here at 6 on both sides. So here's our parabola. Now what happens is we want the inside in between red and blue, which is just kind of a sliver that we're rotating around the x-axis. And so again, this would be a really weird looking shape, but we'll go with it. So we'll set up the integral and then work out what that would give us. This is pi, the integral from, now we've got 2 intersections point here, 0, and then this is intersecting at 2. We want to think about which of these is our outer function, which is the inner function. The red function in this case is the outer one, so that is the 2x plus 2. We'll square that. And then we are going to use the x squared plus 2 second. We'll square that. Both of these we will need to FOIL when we square. And then hopefully we'll have some like terms so that we can not have to do like a billion things. Let's see, this first part will be 4x squared plus 8x plus 4 minus, and we're going to have x to the 4th plus 4x squared plus 4. Whenever we distribute the negative, that'll change some signs. We can also try to add like terms at the same time, like x to the 4th doesn't have a like term, but it will turn to negative. 4x squared minus 4x squared cancels out, yay. 8x doesn't have anything to go with, so we'll have to leave 8x, and then 4 minus 4 cancels. So that's pretty nice that some things cancel. So this is all we have to integrate. So we'll power rule this, negative x to the 5th over 5 plus 8x squared over 2, which would really be 4x squared. We're going to plug in 2 and 0. So negative 2 to the 5th over 5 plus 4 times 2 squared minus 0 for the second part. So all we got to do is figure out what this is. Like negative 2 to the 5th is negative 32 over 5. And then 4 times 4 is 16. So negative 32 fifths plus 16, assuming my paper over here is right, is 48 fifths pi. And so that is the volume of that problem. On the next video, we'll talk about what to do whenever we're not rotating around the x-axis, we're rotating around a horizontal line. So it is similar to what we did whenever we did this with discs, but if you want to go ahead and watch the next video to see how that works, go.